So hi everyone. Thank you to the NSRR team for creating this bootcamp series and inviting me to present Snooz. And thank you to everyone for joining this workshop. So is it okay? You see the writing, right?
Yep, we can see everything.
Perfect. You don't see the notes, you just see the presentation view. Perfect.
Yeah, everything looks
So
great.
my name is Karine Lacourse, and I've been working as a developer for the last 10 years at the Center for Advanced Research in Sleep Medicine. I will refer to this center with the French acronym SIAMS. So what is SIAMS? SIAMS has been created in 1977 by Jacques Montplaisir, and it's around 20 regular researchers, along with a clinic that see annually about 2,000 patients. So a lot of software has been developed to help the clinic and the research So and all of these software have been created mostly by one engineer, and he retired in 2020. So the SAMS decided to create a new platform to include the most important tools developed during those years, and it's called the Snooz Toolbox. So every tool included in Snooz were validated against the original version that we have in at the clinic, and it has been used like for many years. So it helps us a lot to have a robust validation. So what is Snooz? Snooz is a toolbox. Is that in an open access, open source, is custom designed for advanced PSG analysis. The core architecture was developed by David Levesque, who has been working with us for 4 years. But the tools and the module were mostly developed by me. During the past 6 months, I've been working on Snooz almost entirely by my own. However, we recently received a major grant, currently under embargo, and have hired 2 additional engineers who are here with us today, Boshra and Mohammad. And we plan to bring another one soon. This will allow us to make Snooz more robust and address the current challenges we are facing. So Snooz is still in beta version, but I hope this workshop will provide a great opportunity to share our vision with you. I look forward to hearing your feedbacks and hope you will continue to be excited about using Snooz in its future releases. Here's the outline of my presentation. I will start with an overview of the Snooz Toolbox. I will list the key features of Snooz, present a few of the tools distributed with Snooz. I will show you an example of the guided step-by-step interface, graphical interface. And finally, I will share a few notes about the architecture, highlighting its flexibility and collaborative features. I will keep going afterwards with the hands-on session, but we'll go through the steps together later. Here are the key features of the Snooz Toolbox. It is really intended for sleep technicians, clinicians, or students without any programming skills. It's a graphical user interface application that can be installed on Windows, Mac, and Linux. The current compatibility is limited due to our small developer team, but we expect to solve this problem soon. So Snooz has been validated only on Windows 11, Mac, Sonoma, and Sequoia, but only on Intel chip, and Ubuntu 20.04. As you already know, it's open source, but I wanted to add the link here. And we really try to document everything to make it easier to use. So we create the documentation on Read the Docs. Let me introduce the Snooz tool included in Snooz. So we think we have the most commonly used tool in the sleep research community. First, we have tools for importing annotation from various formats, such as EDF+, XML, and text files. We also offer a tool for editing annotation to harmonize them across cohorts or even across different cohorts. Next, we have event detectors, so tools for detecting artifacts. The way we detect artifacts is a bit different than what we are used to see in other tools. We try to imitate what sleep techs are doing. So we try to detect muscles artifacts, also slow wave variation that we can see with breathing artifact. We try to detect burst that could be related to any pop-up of electrodes, and so on. And we also have tools to detect spindles. Two different tools are already included, but we plan to add a new one really soon. We have tools to detect slow waves and oxygen desaturation events. Finally, for more comprehensive sleep analysis, Snooz offers a range of options, including sleep cycle segmentation, power spectral analysis, and various sleep reports, mostly based on the sleep on the expert annotations. Here's an example of the guided step-by-step interface with default settings, which requires no programming skills. During the hands-on session, you will see that each tool has its own interface, but the overall template remains consistent. So in the left panel, you will always see the different steps of the tools that you can access directly by clicking on the steps, or you can use the previous and narrow push button. You will always have a menu at the top where these are the categories of all our tools. And each steps will have its own artifacts that you can interact with. Now is an example of the developer interface providing access to the building blocks of the tools along with additional settings. And these additional settings can be defined in the settings view of each individual built-in block, which can be accessed by double-clicking on it. This view won't be displayed at all during the hands-on session. It's just for developers that you could be interested, that at least you know that it's there. So the right panel lists all the module included in our library, and people can just click, select them, drag and drop them, change the interconnections. So if you're a developer, you can play around. The flexibility of Snooz is made possible by the concept of modules, process, tools, and apps. So modules are the building blocks to create an analysis pipeline called a process. Processes are built from the interconnected module to create a complete analysis pipeline, for example, detecting spindles. And this can be saved in a JSON file. Tools are an abstraction layer over a process that provides a user-friendly step-by-step interface. This is mostly what I will be showing during the hands-on session, just different tools that you can interact with a step-by-step interface. There's also the possibility to run an application within Snooz. The only one we have now, it's a viewer to select section, bad section on the oximeter channel to generate a report for the situation. So in the future, we may have many viewers and they will operate within Snooz. They don't have to follow the strict interface for the tools. Those items are grouped into packages. SIAM's packages are installed with the Snooz Toolbox to provide to user commonly used tools and apps to analyze sleep. User can create their own package and share them, allowing others to import these packages into their Snooz Toolbox installation. All modules, tools, and apps have version numbers, and they are grouped into packages also with version numbers. So this can help to reproduce a previous study. Snooz can also be launched from the command line. It could be useful to run Snooz without interface. So I'm almost ready to start the hands-on, but I wanted to pass through the steps with you before to have an idea what I will show you. So you will start by complete your user profile on the Snooz Toolbox website. We'll have to download the 5 NSRR example recordings. We'll download and install the Snooz Toolbox. And next, we'll convert the file from NSRR, which are XML, to be compatible with the Snooz Toolbox. And I will run a few tools for quick analysis. So to get the link to download the installer, you have to go through our website. So I think from here I can just keep going on my slides, but I don't think I have to really go in the. So this is the Snooz Toolbox, the Snooz website. You click on the download section. You have to complete your profile and click on submit. You should receive an email that looks like this one. It includes the 3 links. You just make sure you select the links for your proper operating system. To install Snooz, you just download the link, the installer, and you open the file downloaded. On Windows, it's quite easy. You just have to run the .exe included in the zip file, and you click next until the end. On Mac platform, because the application is not signed yet, you have to mark it as an exception. So when you download your installer, you just double click on it, you drag and drop the Snooz application in the applications folder, you open a terminal, and you from my point of view, both commands are supposed to work, but for some reason, some people only one or the other works. So just try to mark Snooz as an application. You open a terminal and you just click this command line, but you should have received this file by the NSRR team, and everything is written here that you can just copy paste the command line from here. And the Linux platform, you can install it through the terminal. I think it's the best way. You copy paste this command line. So you should be ready to download the 5 subjects. We provided the link. It's a Dropbox link. So please, this data should be used exclusively for this workshop. So please delete once the workshop is completed. You should see 5 EDF files and 5 XML files. So we are almost ready to start the hands-on, but first I must apologize and warn user that Snooz may crash when loading a second tool after completing a process. The workaround is simple. You have to relaunch Snooz, which doesn't result in any data loss because all the results are saved locally. The tool completes successfully all the times, But when we try to reload a tool, we have an issue when the tool has a picture and it crashes at the time the picture is supposed to be displayed. So sorry for that. We are working on that. So last thing, before we really start the hands-on, it's important to know the supported file formats. So Snooze only supports European data format for the polysomnography signals and a specific tab-separated value file from the annotation. Snooze expects a TSV file containing 5 columns to describe the annotation. So the group and the name is just text label to identify the annotation, the onset of the annotation in second, the duration of the annotation in second, and the channel list associated with the annotations. This list can be empty, especially for sleep staging, for example. It's not linked to any channel. However, to ensure the flexibility, Snooze provides converter and importers for annotation. These include support for EDF plus file, XML, but only the CompuMedix perfusion format, sleep stage vectors saved as a text file, and other files with basic details such as the name, the onset, and the duration of the annotations. Snooze also supports 2 additional formats, but mainly from the members of our lab, because we have agreement with Natus, the Natus company, and Harmony is mostly used in Canada. So you can find these word in the interface, but it's mostly from SIAM's users. So now we should be ready to launch Snooze. So in Windows platform, you just have to write Snooze here in the search bar. For Mac, it's easier if you launch Mac from the terminal, because launching Mac from the terminal allows you broader access to the disk. If you want to launch Snooze from the launchpad, it's okay, but you have to ensure that Snooze has full disk access, and you have to go in the settings for that. So it's just easy to launch it from the terminal with the command line that it was sent previously. On Linux platform, you go on the application and you double click on the Snooze. First thing to do is just to make sure your Snooze version is the right one. So on Windows, it's written here in the title. You should have a beta 1.2.0. If not, you can go and help about Snooze. You will see the version installed, the version released, and you can just click on the right push button to download it again. So again, you should have Snooze beta 1.2.0. Something else that is important to look at, it's if you go to file settings, file settings, package, you will see all the packages installed in Snooze. You should have the most recent version activated, which is SIAM's 6.11.0. Same thing for the SIAM's module 6.11.0. It should be all okay, but if it's the second time you install Snooze, it could not be activated to the last version. You can just reset to default. It could be useful for future use, but now I can see it's the right version. In my case, it's 6.11.0. I will keep going with this yeah, exactly. So the first step we have It's to convert the XML from NSR into our TSV annotations file from Snooz. To do that, we go in the pre-processing category and we select convert annotation from XML. Each tool starts with a page to describe the tool that I strongly suggest you to read that if you are by yourself. But now we can go through together. You click next to reach the first step, or you can also click on the step to have access to the step. So it's usually written what you have to do in this step. Select the files to convert. So you click on choose. You have to browse to navigate to the file you just downloaded. It should be called NSRR Tools Webinar Data. Once you're there, you select all the XML file you just downloaded. When you click on the first one, you can click on the other one. And I'm using a laptop at the hospital, so sorry, it's in French, but you click on open. You should see all your file loaded. And there's no more step to do. So you can just click on run. I won't do it just because it's already done on myself, but it's super fast to run. So I can still interact with it. So if you go back in your folder, you downloaded, now you should have TSV file just close to your XML file. If you double click on it, you will see that your XML file has been converted and we have the 5 columns expected by Snooz. The next tool I wanted to show you is to generate the sleep hypnogram to segment the sleep cycle. So it's in the processing category. You go to the sleep cycle export. Processing category, sleep cycle export. Here again, you have a description of the tool. You can click directly on the next. Again, the first step is to add your files. Snooz usually asks you to open your EDF file, but the annotations file need to have the exact same name and be in the exact same folder than your EDF. So Snooz will look automatically for the annotation file linked to the EDF. So you can open your EDF file. You should see all of them loaded. If you click on one single file, you should see the annotation linked to this file. If you converted successfully your XML to the TSV, and the TSV is saved in the same place than your EDF, Snooz should be able to read directly the TSV file. We can also look at this stage that we can make sure your file has been scored. If it was unscored, it would have been only 9 everywhere. So if I change, I look at for another PSG, the events are slightly different. So we are ready to go to the next step. Explaining how we divide the sleep cycle is beyond this workshop. What is important for me to show you is that we have a few sets to compute the sleep cycles, few sets of criteria. So you can select different sets of criteria based on these. it's from different papers. The most difference is it's mostly based on the minimum duration of the non-REM period and the REM period. And these criteria are different if it's based from it's for the first cycle, middle cycles, or life cycles. Another important features is, for example, with hatchback, we have to, the nights have to end with a minimum of 5 minutes of non-REM to validate the last sleep cycle. So it's really popular to include the last incomplete ending for your analysis. But you can also include when there's it's not the expected sleep cycle because the subject goes directly in REM. So it's really popular to use hatchback and include all cycle, even the one that you're incomplete. So you have all the information where the criteria are from, and you can just click and look at the paper. So when you define how you wanted the sleep cycle to be delimited, you can just click on next. And you have to define where to save the output. As a sleep report for the court is going to be generated. So every subject will be added in the report, and you will have each sleep cycle of each report in one report. You have to specify where to save it. So for me, it's already generated, but I'll make the whole. So we can just call it sleep report. Mm. If you write it correctly, it should be written in the line edit here. Also, an hypnogram picture will be generated for each recording. You can decide to add a suffix here or not. It's okay. And now you should be ready to click on run. It's kind of fast, I can do it. You can go in the folder you just downloaded. You should see the PDF hypnogram generated. So it's probably something that all of you know, but the y-axis is the time in hour, the x-axis is the time in hour, and the y-axis is the different sleep staging. So in green, it's the non-REM period. In gray is the REM period. So here we have like 1, 2, 3 complete sleep cycle. And the rest, there's a long non-REM period and a really short period of REM, but it was not enough based on the criteria we decided. So it's why it's red, because it's incomplete. So I won't look at all of them, but you have different pictures based on your EEG recording. Another tool I wanted to show, it's the sleep report. Okay, here. So you go in the processing category and you click on sleep report. So again, you have a description of the tool. Here I'm going to read a little bit on it because the tool is a little bit more complex than the two previous one I just showed you. This tool generates 3 types of reports. The common sleep report, which details the distribution of the sleep stages across sleep cycle or part of the night. It also highlights the transition between different sleep stages And you will find also very common sleep variables such as sleep efficiency, sleep onset, and so on. The second type of report is event sleep report. It provides a breakdown of selected event by sleep stage, cycle, and part of the night. So these reports are really based on the expert annotation. So you will see that we have pre-configured many reports for you, such as the arousals report, the respiratory events report, and the PNMS report. So the last type of reports that can be generated by this tool is the temporal links report. This report describes the relationship between two selected events within a specified time window. So, such as the occurrence of the event 1 starting before the start of the event 2, or the percentage of events 1 overlapping with the events 2. This kind of reports can be useful to know a relationship between hypopnea and arousals and this kind of stuff. So for the rest, I will just show you the rest of the tool. So you click on next. Again, you can also select directly the step. For the first step, we have to add our files. We click on the add, we select all the EDF. Click on open. You should see the list of EDF just loaded. For some data format, the identification from the patient can be displayed here, but it's not common for EDF, and these these EDF were anonymized. So we are ready to go to the next step, which is the events report. So I click on the events report. I will describe a little bit the panel here. The first panel is the list of subjects we just added. We'll have a counter for all the report we will add during the definition of this tool. So if I click on one single file, I can see all the annotation included in the TSV file. The goal here is to generate reports based on different annotation. For example, arousals. Here, the scrolling menu is all the predefined report we added in Snooz. So you can generate arousal reports based on the arousals annotations. You can add these reports only for the current EDF or for all the EDF you just loaded. We can see the report count just increased everywhere because there was the arousal annotation in every EDF file. So we'll have an arousal report with all the variables linked to each of the EDF. If we click on the arousal report, we can see how it has been defined, but it's quite simple. Every annotations that the duration is between 3 and 30 seconds will be kept. But this report is super easy, but you can create any report you want. You can also modify the report by clicking on the modifying. But there's also a more complicated report. But it could be just too complicated for now, but let's add at least 2 other reports. Another really popular report is the respiratory events report. We have obstructive apnea, hypopnea, and central apnea. That's all annotation that could be added to the respiratory events report. Let's just add the hypopnea. So I select the respiratory events report, and I can add to all the subjects. So the report count is increased to 2 for all of them. Again, this one is also super simple. We just keep a minimum, we just keep annotation that apnea that lasts at least 10 seconds. But a really interesting one is adding the PLMS for periodic leg movement in sleep. So the PLMS should be added on leg movement annotation, which we have here. So you select the PLM and you can add the PLMS report for all of them. And if you look at it, it's a bit more complex than the other, because I don't want to go in details, but the idea is you have to look if the leg movement are really periodic, that you have the concept of having many events during a series. And also these events, the leg movement must not occur in the same time that there's a respiratory event. It's why this is great to show, because we added hypopnea in the respiratory event. So any leg movement that's occurring in the same time that the respiratory event will be excluded from the report. So the interval written here, like minus 3.5 to 8 seconds, means that the end of the respiratory events, this is the interval between the ends of the respiratory event and the start of the movement, the leg movement. So it's just to show you, and this interval you can argue that it's not the exact number that you want. Even in our lab, this number has been changing a lot, but you can modify them. Sorry. By default, only the the report is going to be generated. But if you're interested to know every events that are kept in each report, you can check the TSV event list, and you're gonna have in the output. The only step that we have to define is if we want to have the temporal link report. So what is really common to use in our lab is to look the relationship between the PLMS, the periodic leg movement, and the arousals. It's going to be looked in a window of 0.5 seconds. So in each window of 0.5 seconds, you look at the occurrence of one event compared to the other events. But this could be also changed. And you can apply this relationship to all the files. So 4 reports will be generated for all these EG reports. The last step is to define the output. So if you want the general, the common sleep report with the sleep efficiency and so on, you have to check the first option here. It should already be checked. You have to precise where to save all these reports. So usually you create a new report, a new folder. And you select the folder. If you had specified correctly, the path should be written here in the line edit. You can add prefix to your report or not. And here is the list of all the report that is going to be generated. In parentheses is the number of EG recordings that is going to be added in the report. So we are ready to run the analysis. You can click on run. It's really fast, but it's already run. So I saved everything here. all the TSV file is the report generated. For each report, you will have a description file to give you the definition of all the variables included in the file. So at the beginning, it's mostly a description of the about the subject, if it was available. You have the cycle definition that you choose for your analysis. I forgot to mention, but at the beginning of the tool, you always have the sleep cycle definition, which is exactly the same page that I showed you before. There's by default or lab or using hatchback, but you can decide to try minimum criteria. So it's not in a step because it's usually quite stable during analysis. You don't have to modify this each time. It's why it's written in a common setting at the beginning of the tool. And you don't have to define these each time. In our case, it's always the same. It's why. But it's gonna be written in your report in case you don't remember. So here it's the common sleep report, and because data is analyzed, there's nothing at the beginning, but all the variables have been generated. But it's really hard to look at this like this. But these are the definition of. So you have the sleep latency, depending of the different criteria. The number of minutes of each sleep stage for different part of the night. You have the sleep efficiency, depending of many things. But the idea is you have all the variables, and it should be well described. And there's always the options to give us your feedbacks. If you are missing information, you just click on it, and it's in French, but you can change it to English. And some of the variables are already defined for you. You can write your name or not. And you can just give us feedback on this. So the only things I wanted to show you, it's because the first tools I showed you was about analyzing annotations, but now we can analyze the synapse. So what I suggest is to go in a pre-processing category and try to detect artifacts. So pre-processing category detects artifact. And we have picture of example of the artifact that we can detect, such as like slow electrode pop, or ear glitch, or persistent noise, or power line contamination, events, baseline variation linked to breathing artifact, or a muscles artifact. So in this tool, we have different detectors that you can choose to run on your data. So the first step, again, is to add your file. So you click on Add Files. You'll select all your EDF files. In the EDF format, you don't have the idea of montage, but in other format, it's really important. So from here, you just have to select all of them. If you click, the first panel is really the list of your EDF. If you click on one EDF, you will see the annotation linked to your EDF. To select all the montage, you can highlight all your EDF, and now you can, by selecting your montage, you will see the channel linked to the montage. So if I choose only one subject and I select the montage, I will see the channel only for that subject. Because we usually want to detect artifact on all the EG channel, I strongly suggest you to select all your EDF file. And here we can see that the only EG channel we have is C3 and C4. The other is a reference. So in the search bar, you can write your C3 channel and select them all. It's quite useful when you have a big cohort. In this tool, you also have to define the type of the channel, because we try to detect the muscle artifacts, and we use the EMG channel to enhance the artifact detection of the muscle corruption on the EEG. It's the only tool you have to define the type of channel, but it's you have to select the channel and just click on the arrow close to the EEG in the alias. If it doesn't work, you can just write it manually. So we can remove what we have written in the search bar to see all the channels available, and we can see that the C3 has been selected everywhere. To enhance the muscle artifact detection, I strongly suggest you to select the shin channel. So to make sure we select all of them, we can just write I will already filter for the shin. We can select all of them, and it identify the shin as EMG channel. You could also add the left channel, but only one EMG channel is enough, and it will just increase the processing time, adding all of them. But it will still work. So it's completed. We added the subject, we select the montage, we select the channel we want to run the detection. Only channel marked with added in the EEG alias will be used to run the detection, and the EMG is just to enhance the muscle artifact detection. So we're ready to go in the next step. If it's just an additional step, if you want to add filter, if you know that you have a huge problem in low frequency band and your research question is not related to low frequency band, you can just filter them out. So same thing with the power line, you can add a notch. You just have to click it and select if you want to be around 60 Hertz for Europe, or 50 Hertz for Europe, or 60 Hertz in America. But for now, you can just let it there. And here it's where you have to select the artifact detection you want to run on your data. At the beginning, you can decide to have specific name or label for each of the detection. If you want specific label, you can just check specific to each detection and go in each page of the artifact detection and change the name, the group of the detection. But it's not that useful and it's longer to process than just keep going with a common name of all the detections. Here's all the list of the detectors. It's possible to detect flat lines, high frequency bursts, persistent noise, power line contamination, baseline variation, muscle artifacts. By default, they are checked, but you can remove some of them if they are not working on your data. There's also a strategy to make the detections more precise or more sensitive. It's just suggestion to how to increase or decrease the thresholds. The thresholds are listed for every detectors. So we worked up small value for all of them, but let's say that at least you will start with the default thresholds. And there's explanation for every detector. The last part is because some of the thresholds are data driven, so they are defined from statistic from the data. So it's better to include in this statistic only stages that it's the data it's expected to be cleaner. So in our cannot score, there's a lot of artifacts, and maybe you want to exclude them from the statistic to define your thresholds. If you're looking, if you're working only on RAM or just in N2 because you're interested in Spindle, or in RAM because you have RBD patients, maybe it's better to base your statistic only on those sleep stages. So there's no more step. You can just click on run. This tool is a little bit longer to run. You can expect like 20 seconds, maybe per recording. So in my case, I can just go to the next tool. The last tool I wanted to show you is the spindle detection. We have the A7 detector and Martin. These two tools are exactly the same. The only difference is the settings for A7 or Martin. I will show you the difference. But because Martin is way faster to process, I will strongly suggest you to use that one for the workshop. Since you're probably running the artifact detections, I will just show you around a bit. So to show you the difference between the two tools. So we will be running Martin, but I want you to show just the A7 to show you around. So all the first step would be exactly the same. The only difference is the step detection settings. You will have a specific page for A7 because it has different thresholds. So if I go back to Martin, the first page, then it's always to describe the tools. Again, in the common setting, you can decide how to segment your sleep cycle. Your first step is to add your files. So you click Add Files. You select your EDF. Again, if you click on one single file, you should see the annotations. If you select all of them, you'll be able to select the montage. And now the channel. Since we detect the artifact on C3, I strongly suggest to detect the spindle on C3. So you mark C3. You can select all of them. So it's the definition of the step one is completed. The second step is non-valid events. Then you have to select events that disable the spindle detections. If you click on one subject, you see all the annotations. But since you run the artifact detection, you should see art snooze in your list of annotations. The strategy is to select all of them and use the event group search to filter your event. So it's easier to select all of them. So every spindle detection that occurs in the same time than an artifact, it will be removed. So when you select the artifact for all the cohort, you can go on next. Here it's where you define some criteria about detecting new spindle. You can decide to limit the length of the spindle detected. You have to choose in which sleep stage you want to detect spindle. You can also decide to exclude REM period because it's possible to have REM stage in it's possible to have N1 or N2 or N3 in REM period. It's why some people prefer to exclude them because it's not real non-REM stage because it's included in a part of the sleep cycle, which is more related to REM. It's why. So if you want to change the settings of the Martin detector, you have to click on this specific config pages. These thresholds are the ones that have been used in the publication listed above. But generally, you don't have to modify the definition of the setting when it's included in the config page. It's what is really important is to config every steps. So the last steps, it's how you define your output. Our spindle events will be added in the accessory file. Exactly the same strategy that the artifact that we detect before. These are the characteristics that you can generate for each spindle, or you can generate cohort report, which will list the average characteristic per channel per subject. So in this case, if you are interested to have the cohort report of the spindle, you have to select where to save the report. So, if you define it well, where to save it, it should be written in this line. And is it line? You can also export a file per recording, which will list every spindle, like the onset of the duration of the spindle and all of these characteristics, such as the dominant frequency, the average frequency, the peak-to-peak amplitude. So you will have like a huge report for all of the recording. So there's no more step to define. You can just run it. So I created the report file called Martin Spindle report. So we have one subject per row, and all the characteristics like the amplitude peak to peak in M3 for the sleep cycle 1 for each of them. And again, if you want to have the definition of each variable included in the report, the underscore info file is also generated. So you have an explanation of each of them, like total N1 valid minute, it's the valid period for detection, the valid duration in minute of the sleep period in N1 stage. So you have like the definition of every variable included in the report. So it would conclude the hands-on. I just have a few slides for the end of the hands-on. So we are working to ensure compatibility with more operating systems, especially Mac. We have to support M1 and M2 chips. It's going to be our next priority. We would like to also work for being able to read high density EEG data for whole night. We have members of our team that are working with high density, but really on short duration, like only 5 minutes because they are working with anesthesia. But it's something that we have to figure out soon. We would like to upgrade our library, especially to resolve the issue of crashing, of snooze crashing. It could be solved with upgrading these libraries. We plan to add an automatic sleep staging. I'm also working on developing a RAM detector and a RAM corrector, and also an ECG detector and ECG corrector. And 2 members of our team are working on connectivity metrics, and they have created their specific package that could be distributed soon to the community. Here is a list of our reference. So thank you all for listening and participating. I'd also like to thank you, the NSRR team for giving me the opportunity to present in this bootcamp series. And here is the member of our team at SIAMS. They are the ones that are most involved in this development. So thank you. So Mike, do you want to?
Sure. Yeah. So thanks so much. So a lot of us we've been doing our best. It seems like I'm going to shut off my camera because it seems it's frozen.
Do you want me to stop sharing?
No, that's okay. That's okay. There's been a flurry of questions that we've been trying to answer in the comments during your chat. And there are a couple of big picture ones that I think maybe you could address now. And just before we do, I wanted to say, first of all, thank you. And also, we will have this recording available on the NSRR webinar site. I know there's a lot that was going on and a lot that happened very quickly. And so it'd be great to be able to rewatch this, so don't worry about this. If you have any issues, I ask you to please document them very, very carefully. Screenshots are always good, and send them to the presenters. I think this is going to be helpful feedback for them, both in terms of the presentation and also maybe any rare events that could be causing bugs. So please feel free to do that. So we'll answer a couple of questions now, and then we're going to head to the breakout session for those who have that link. And if you do want to be added to a breakout, a future one, please contact the presenters, and maybe we can get a list and set up another time. So the first question we have is, would the event detection interface be a good tool with which to identify eye movements? Supposing, for example, we wish to quantify the density of eye movements in REM stage sleep.
We are working on one, and it's a real challenge, to be honest, but we are close to be happy with our results. So eventually, but we have to publish before that, including in Snooze. But yeah, we are working on that.
That's great. Are there, have you thought about including a manual sleep staging function? That would be great to do someone's own scoring in the same software.
I know, but it's such complicated, and I've been looking at open source viewer, and we have been working closely with EDF browser. And thanks to Tunis, the author, he has been implementing so many features that we asked him to do. And because we wanted to provide a way to score sleep staging. And seriously, right now in EDF browser, there's everything possible. But in our lab, because we also used EDF browser to review the artifact detection, it's the way that the artifact detection are displayed. It's not that easy to select them. It's possible, but it doesn't work all the time. It's not that robust. So for my sleep tech, it was too hard to move or to change or to slightly make the annotation longer. So they do prefer use the Natus viewer. And because of that, in the Natus viewer, they are able to score the sleep staging. So because of that, we don't need a software to do that. But I really wanted to offer an open source option. And for me, it was way more efficient to use EDF browser because it has been created for so far away, so long time ago with many, many, many features that just thinking about something, not even close to EDF browser, but just to creating that will take so much time. So for now, it's better to use the EDF browser. It's totally compatible with Snooze. You can just import the TSV file out from the output of Snooze and it works perfectly. But everything it's possible that we create at least a few viewers, but to be honest, it's going to be long when the time is going to be possible to score manually sleep staging in Snooze.
Great. There was another question about other spindle detection algorithms like YASA and other stuff. Are there plans to include more?
But the following detector we want to implement is Sumo, because it has been validated on the MODA gold standard, so we trust this dataset. But it's super easy to implement stuff from YASA within Snooze. So we will probably try to integrate a few of them. And we'll start with the automatic sleep scoring. And I tried the rapid eye movement detector. So the next step could be sleep spindle, but this I remember that they started implementing A7 as the spindle detector in YASA, but they modified it a bit. But I didn't find any publication to know what was the exact modification. So I'm not sure if we'll implement the exact same thing that it's already included in YASA.
Great. Do you, can you manually annotate segments?
For now, the only way to annotate segments is for the oximeter. So it's not that useful. The way we annotate segment is we use EDF browser. And from EDF browser, you can export a TSV file. And it's a TXT file. You can export the TXT file. And in the importer in Snooze, you can import that file.
Great.
It's the way we are working.
All right. And then I think the last one that I'll add is sort of two-part. How do you see Snooze working on how do you see Snooze working on let's say home sleep recording devices with limited channels and also on rodent data?
On what?
Mouse data, rodent data.
For the first part, there's no limitation about the channel, if it's the first part of the question.
How do you for things like home sleep recordings in which there's very limited channels and limited annotations, how do you see Snooze functioning?
That I don't understand
Are there going to be do you need a full PSG to run this, or can you do it with like a single
Okay, it's what you mean. It's but the most of the most of the tools are can be run on only one channel.